All right, anyway, so I got a little bit more lecture. Might as well start that way this morning. It seems to be, before you all get too densely locked into your quest for those certifications, which I highly recommend. We can go through a little more of general information about IP version 6. So I've got that here. This one here changes. All right. So, yeah. They don't. And so I've got a USB drive going around, hopefully with Packet Tracer and with the Cisco lecture, which I'll show you later. Good? Yes. Or you can just download the latest version of Packet Tracer. I don't think you can do this with 5.2. I think you need 5.3 or later. I'm not exactly sure which version you need, but I know some students, one of our labs had a version that was too old. And it was only about a year ago he put it on there. So apparently complete support for IP version 6 is a fairly new feature inside Packet Tracer. So we've been through these and those. And so there's only a few more general facts about IP version 6, but here's probably a good place to start. IP version 6 has what they like to call a simplified header. Because taking a look at the old IP version 4 header, a whole lot of this is actually not that important and not that useful, and it was removed. Fragmentation in IP in layer 3, you may remember fragmentation at layer 3 is for the birds. It is intended to be used if you have a high packet size link routed to a low packet size link through a low bandwidth network, and you actually have to cut packets up. It would be a whole lot better to do your segmentation at layer 4. Layer 4 is intended for that. It's got the segment offset and the error correction routine so that you can send things over TCP, they get cut up into chunks and delivered correctly. But if the TCP segment size is set to a size larger than one of the links in between, then it gets rebroken again at layer 3, called fragmentation, and this is an inefficient process. It turns out to be a bad thing, and you're not supposed to do it in IP version 6 at all. Instead, you are supposed to go through a detection process to choose the correct layer 3 segment size and send it at the right segment in the first place. So it does not happen at an intermediate router anymore in IP version 6. It happens only at the source, intending to make it more efficient. Anyway, and so the result is this fragment offset and identification fields have been omitted from IP version 6. You're not supposed to have layer 3 fragmentation anymore at an intermediate router. Yeah?
So Sam, what happened when you have this descended from IP version 6 to IP version 4 router from a fast link to the slow link?
Well, you bring a couple issues there. I mean, we've only talked about going from 6 to 6. Now, going from 6 to 4 is a whole other issue.
Because what I'm saying is that when you acquire any company,
yeah.
and it happens to be IP version 4, and
yes.
it happens to be IP version 6, you put that router in between to bridge them.
Absolutely. And if you do that, you will have, there are several different transition technologies, but your device that converts 6 to 4 will have to be intelligent enough to reassemble things and repackage them. So that may involve effectively a kind of fragmentation. They'll also have to change the source address. So, I mean, that's like a proxy, essentially, or a bridge. It's got to basically convert the whole protocol. So there, the segment size might change in principle. All right, and the other thing is if one's faster and one's slower, of course, that's not a problem anyway. The router will just hold it and forward it. But it's the size of the packet that would matter. Anyway, so these things are gone because there is no more fragmentation. The options field is gone. Now, I actually got involved in a thing. Maybe I'll show it to you here. I'm not quite sure what to make of this. I started learning IP version 6, completed the Hurricane Electric certification, started teaching it, and then I got a strange, I know I presented at DEF CON, a presentation like one of my general overview, motivate why we're running out and we have to change. And there was a huge crowd of people for more than an hour there's an overflow room you go for questions, and people were there with all these questions, and as a result of that, one of those people asked me, why did they make IP version 6 incompatible with IP version 4? Why isn't it backward compatible? And I said, you know, that's a really good question. All this nonsense is caused by the fact that it's not backward compatible, which is a really strange way to redesign it. And I got an email from a guy who's working for the military, so he cannot speak for himself very much. He got to go through quite a lot of hoops to publish things, but he actually wrote an alternative. IPv6.info. I bought the domain name, and I became the champion of this for a while. This is an alternative to IP version 6, which is backward compatible with IP version 4. And at first I said, this has got to be the answer. You don't have to upgrade anything. Because in IP version 4, you have this options field. And this thing can have like up to 60 bytes of more stuff in it. And it's hardly ever used. So why don't you just put your 128-bit addresses in there and keep on using IP version 4 forever? And we had a planner. He's written a draft RFC, and he's revised it already a few times, and this seemed a whole lot smarter to me, IPv6. So I put up this page, and I talked about it on a podcast and such. There's really enough room in the options field in IP version 4 for all sorts of good stuff. 128-bit source and destination network. But anyway, nobody was interested. This has never been implemented anywhere. We wanted to get volunteers to help write the code and start making IPv6 routers and gateways and see if it will go. But nobody was interested. I put up a page so I can get some comments, and Dan Gooden, who's a very good technical writer at the Register, went and researched this, and BGP experts say this is completely hopeless because BGP already uses the options field, and you can't go using it for something else. And I don't know if that's true, but anyway, the ship has sailed. We're all going to IP version 6 for better or worse. We're all breaking backwards compatibility. So I just thought I'd mention it in passing. That options field is gone in IP version 6, and it did seem like a pretty good idea. And in retrospect, you know, I'm not entirely sure that the wise heads planning this in the 90s were really correct that they had to break IP version 4 compatibility to go to IP version 6, but that is where we're at. So that's why we're in. Anyway. The header is much bigger, but it's much simpler. There's really nothing there but source, destination, and a few other things. Payload length is there to specify how long the payload is, not including the header. Hop limit is the new name for what you used to call TTL, which is a whole lot more sensible because remember, it's supposed to decrement by 1 per hop or 1 per second waiting in the queue, but it never waits as long as a whole second in the queue. And in fact, the dirty little secret is nobody ever bothered implementing that in their code anyway. So in fact, time is never really used. So it really is the number of hops. And actually, this is used creatively and intelligently in IP version 6. Remember I mentioned there is multicast to all nodes, which you use to find all nodes, to replace ARP. And you don't want anybody doing that except people on your local area network. You don't want remote people sending in multicast to scan your network and find out what you got. And the way you do that is it only accepts packets with a hop limit of 255. So the next one hop will kill them. So they can't escape your network. I don't know why we didn't do that in IP version 4. But things that should be local are set with a hop limit so that they cannot leave your network. If a router forwards them, they'll exceed the hop limit and be gone. So that makes sense. And so that's one use of it. Other than that, it has the same use it had in IP version 4. Nothing will hop more than that many times before it just gives up and throws it away and sends back an ICMP error message saying, I threw away your packet. If the hop, so that's the point. Another thing is flow label. You know, flow label has not been implemented yet in any real practices, but the idea here is to go to faster processes than routing, like MPLS essentially. This has been an idea that's come around quite a few times. I've got an article about flow routing. Flow routing was supposed to replace IP routing. That's not vaporware. There are devices you can buy that implement flow routing and supposedly are 100 times faster than IP routing on the same hardware. And this comes from the fact that in IP version 4, for example, you have a packet. The packet has to be compared to that routing table of 400,000 entries and then forwarded to the next one. Then at the next router, it is again compared to a list of 400,000 entries, and on it gets maybe 10 or 15 hops to get it where it's going. Then the next packet comes, going to the same place, and repeats the entire process over and over again at every router, which really makes no sense at all because one packet only has about 1.5 kilobytes of information in it, and everything is bigger than that now. So people are downloading movies on Netflix. After the first packet is coming another 10,000 packets, the same size with the same source and the same destination. And every single one of them has to go through the whole routing table at every hop, which doesn't make any sense. The first one should blaze a trail, and the rest should just follow it like ants. It should just have a flow number in the front, and they should just follow the flow. Then they don't have to bother doing any further calculations, anywhere unless something actually changes, like some link goes down during the transmission, which is rare. That's flow routing, and it makes a lot of sense, and there's a lot of proposals for that. So in order to permit that sort of thing, the flow label is explicitly included in IP version 6, but it's not implemented yet. However, logically, it does seem like a really good idea, and like within not too many years, one would expect this to start being used. But right now, it's not a common thing on the backbone, although it has been proposed. Anyway, you've got traffic class, which is the same thing as type of service, essentially. So you can specify your high priority voice over IP traffic and deliver it faster than your web pages and email. The version is 6 instead of being 4, of course. And then you have this strange stuff here. In case you want to add more stuff to the header, you can expand the header as big as you want, unlimited, which is, by the way, a pretty good idea. And if they had thought of that in IP version 4, there'd really be no excuse for not keeping backward compatibility, because we could just make the IP version 4 header as big as we have to, and we would be able to add all of this to that without running into the limit of how big the options field can be. So, you know, they try to think ahead and leave room to expand the protocol, but they didn't leave enough room in IP version 4 to really expand it, to add IP version 6 and keep it backward compatible. And I would, in principle, it seems to me that this process means they will never have to go to anything beyond IP version 6. Because even if someday you decide that you need to have 10,000 bit addresses, you can just add it and still be compatible with this. Anyway, that's the game. And then you can have hop, you can have another header and another header and another header, as many as you want, 10 or 20 deep. And there are some options that do that, including the deprecated routing header 0. There is a routing header 0, which was essentially flow routing, where they call it, I forget what they call it in IP version 4, but there's a process where you can tell it exactly what routers to go through, which turned out to be a security nightmare and deprecated, and it's already been deprecated in IP version 6. Before even being implemented, it's already deprecated, because you can do the same thing. You can specify it to go stupid places, like around the loop. But there are other possibilities for that routing header, additional routing headers to be put in there. So that's the game. IPv6 is simpler than IP version 4. So the IPv6 header is a fixed length unless you use those optional additional headers. Everything else goes in extension headers. There's no checksum in the header, which, and again, in retrospect, was kind of a foolish idea. There's going to be error correction at layer 2 anyway. And if you use TCP, there's error correction at layer 4. So you really don't need to have another layer of error correction at layer 3, and it slows down everything, because it means that every router that just wants to forward your packet has to recalculate this sum because the TTL has changed. And that's just a pointless waste of time, so they took it out. There is no checksum for the header. All right. You have payload length, and like I say, hop limit is a better description of what TTL really is. It really has nothing to do with time anyway. It was just a misnomer. These are all gone. ARP, ICMP, and IGMP all rolled into ICMP version 6. In IP version 4, ever since Windows Service Pack 2, everybody doesn't implement ICMP hardly at all anymore. You can ping machines all you want, they're not going to answer. That really frustrated my Cisco students. Step 1 is turn off the firewall, and until I made a ghost image that already had the firewall off, that was the reason a hand was up through all of my Cisco classes. I can't get my network to work. You forgot to turn off the firewall on the PC again. That's why it won't ping end to end. You know, so, and so anyway, everybody blocks ICMP anyway, but you can't do that anymore, because ICMP is replacing ARP. And you're not doing any networking at all without ICMP version 6. So you have to let it through. So it's coming out. Has to be fully implemented, has to be supported, or you're not getting anywhere. So ICMP version 6 looks like this. Message type, code, a checksum here, and just a message body. Very simple, not much to it. You can't fragment it, but I don't know why you'd really want to. All right. I mentioned this already. The MAC addresses are used to create the interface addresses if you use the recommended procedure of SLAC, stateless auto configuration, and that means that people can find you. So it might be better to use privacy extensions for SLAC, which is what Vista and Windows 7 do by default, where it does not use your MAC address, it just uses random numbers to fill it in, and then does duplicate address detection, which is necessary anyway, where it just checks to make sure nobody else is using the same address on your same local segment, and then you're fine. All right. DNS, you've already begun doing this. Their new record was added to the DNS table, the Quad A record. That contains your Quad A IP version 6 address. So you can have a address of came.net reversing to this thing, and that means when you try to do reverse DNS, you have to have this horrible looking thing, which is the IP version 6 address backwards, character by character in base 16. And that's why if you were to use anything other than a /64, /60, /56, if you were to use a /57, you could forward route packets to it, but you could not resolve that domain with reverse DNS because there's no way to express this name. You need something between these two letters in the file name. Unless you use the optional 128-bit version of that in binary, that doesn't seem to work when I try it. But in principle, it is permitted. Anyway, that's the game there. That's why ISPs are supposed to give you a /48, or if they're absolutely convinced that you're a really small company, you're never going to grow, they could give you a /60 or /64 if they have this unbreakable habit of being stingy and scared of handing out too many IP addresses. I remember one of the funny things I saw recently on the internet is somebody wanted IP version 6, he went to his internet service provider, and they gave him a /126. So he could have like 4 addresses. And he said, what's going on here? He said, well, they don't know what they're doing. You know, they had this habit of IP version 4, right? We're going to give you 4 addresses, 7 addresses, 8 addresses, and they just assume it's the same. I think they might have given a /120, but you know, it totally fouls up the whole system. But it's early days, and a lot of people don't know what they're doing. So you've seen this, you've all done in your project. If you do set Q equal quad A, you can resolve to these quad A records. All right, so for migration, dual stack nodes are where we definitely want to be for the next decade, where everybody's running IP version 6 and IP version 4 on your servers and most of your networks. This is what Windows does by default, turns on IPv4 and IP version 6, which means you have tunnels being created. You can also connect parts of your network that have only one type of IP with other parts through tunnels or through address translations. IPv6 is supposed to have these advantages. These are the carrots, and I must say this is largely fraudulent statements. And that's why it hasn't really been adopted, because everybody that tries, it's just like Windows Vista. They have a list of why you need to deploy Windows Vista instead of XP, and it's all just lies, because there's no reason you need to deploy Vista instead of Windows XP. And there's really no reason why your functioning network has to go to IP version 6. If it's working on IP version 4, converting to IP version 6 will take a lot of time, a lot of work, and you'll end up right where you started. But you got no choice. Anyway, here's what you're supposed to have: more efficient address space allocation, which of course, anyway, that's the idea. They hopefully won't snarl it up as much, and that will actually make the backbone routers run better, and that's actually good for major ISPs that are running the backbone, but small companies don't know or care. That's not their problem. End-to-end addressing, we've already talked about this. Now, one good thing about end-to-end addressing, though, is you should be able to reach mobile devices more easily directly with IP version 6, because theoretically your IP address will go right to the device all the time and not have to go through translations on the way there. But in practice, people are already translating like crazy, and there may be more to that than just bad habits. There may be actually enough little problems in the realistic implementations that you really do have to translate. Fragmentation only by the source. That's kind of nice. I don't know how much trouble is really caused by fragmentation anyway, though. I think now that we don't have too many token ring networks around anymore, I think there isn't really that much variation in packet size. But anyway, routers don't calculate the head sum, which is a small thing. Multicasting. IPsec is available, but it's hard to implement. The key management is irritating. I don't have an IPsec lab. It would be quite a job to set up an IPsec lab. And you can do IPsec in IP version 4 anyway because it was backported, which is the same thing that happened to Vista. All the goodies in Vista were backported to XP and put in Service Pack 2, so there really wasn't much left to sell it. And all the goodies in IP version 6 were backported into IP version 4, so it's the same situation. ICMP, there's all the configuration I've described. And the header structure is more intelligent, but you know, most of this it's theoretically and sort of mathematically more pure. But from the end user's perspective, and even from the local network administrator's perspective at your company, there's nothing you can do now that you couldn't do before. Anyway, here's the kind of thing you might have. Here's a example of a real IP version 6 network. So they'll have a customer network here, which connects here, And they decided to give these guys V6, but the link between them only allows V4, so they set up a tunnel. Now you're using these free tunnels here, 6SS, which you may have already noticed is really unreliable and sleazy. Halfway through the class last time, Amsterdam seemed to go down, a bunch of people couldn't connect. But you can make your own tunnel between your own tunnel servers, and then it will be as reliable as the rest of your infrastructure. You're not relying on somebody's free service. And that's what you might do. So then you'll have a level 3 MPLS core here. You can run an IPv6 or IPv4 over MPLS and tie it up as much as you like. And then you can have IPv6 connections here or tunnels. So this is the real networks that we're going to create in enterprises in the next 5 and 10 years. We're going to have blocks of IP version 4 only, and then lunks of IP version 6 going through gateways and tunnels connecting different portions. And this is the way the cell phone network already is to route internet traffic through Sprint and such. Sprint and Verizon have 2 different systems. I might have them backwards. I think it is that Sprint actually gave everyone dual stack on their cell phone. It has a version 4 and a version 6 address, and Verizon gave them version 6 only, or else it's the only, and they translate everything with a 6 to 4 gateway at the main server. But these are the 2 possibilities that you can go. Dual stack for cell phones was considered to be expensive and undesirable because it basically means you have to have twice as much support on the cell phone, but one cell phone manufacturer has actually gone that way. Others have gone with V6 only on the cell phone. The one that went to dual stack V4 and V6 found that they ran out of the version 4 private address space because it's only basically the 10 subnet and change, 192, 168 and all that, and they used it over 40 times. So there's actually dual layers of NAT there, because even after they get a private address, they then have to figure out which of the 40 possible private address ranges using the same numbers it might be to resolve it on IP version 4. And of course, in IP version 6, there's no problem. Everybody gets their own address and you'll never run out of them. Anyway, so here's a summary from my ETF of the addresses, which is a nice correlation back to IP version 4. So : : is the same thing as 0000, : : 1 is 127.0.0.1. The ones with FFFF in the middle are the equivalent, are IP version 4 mapped addresses that can be used, which you talked about. And unique local addresses are the FC addresses. These are what you really ought to be using for point-to-point links on serial cables, although I don't think I did it correctly in the packet tracer activities you got there. But these are addresses which can be used within your network but are not supposed to be routed to the internet. The FE80s are the ones that work only on the local links. The FC100 are not intended to be routable on the internet, but you can route them through routers. And on the other ones, starting with 2001, are your public addresses that go out on the internet. So these FE80s are like the 169s. They're only intended for local traffic. And the FC100s are like the old private address space here. Perfectly routable, but not intended to be routed on the public internet. So they should never resolve to domain names and such. Those are the general classes of IP address. And there's a whole lot more here, including quite a few more details there I haven't gone into in this class. That's a really, if you want something, in my opinion, to throw at the 106 level, this is the best source material. This talk here from OpenWall quite a few years ago. It presents things at a reasonable Net Plus level. All right, anyway, I got a few iClicker questions, so let me see if I can get this app going. I think it's in my downloads folder.
Where's that flash drive right now?
The flash drive made it over to you, right? You got
Over there.
Okay, great. And
Everybody else done?
and someplace turning point anywhere. That's it. Turning point anywhere. Application. There it is. All right. So I only have a few of these, but I think these are good for you. So. There we are. Good. Well, let me just start it. And what? I've got a receiver. Fine. I'll pull it out and plug it in again. USB. Light comes on. Okay, good. Now it believes me. All right, good. All right. So, which one of these is not present in IP version 6? And theoretically it's listening. Yeah, polling is open. Ah, good. There comes a vote. Good. You have these little things should be somewhere near you. Are you all using these things in your classes, these audience response systems? They make my students very happy. Yeah, the students my first year I used them. At the end of a second lecture with them, I'd have a vote. Do these things good or bad? And every single class, at every size, at every level, all voted virtually unanimously that these are great. They make lecture better. Rather than just listening to some guy drone on for an hour, you have a little game show in the middle. It makes them happy. Anyway, so all right. Let's see what we got. The first answer is the most popular, and I like the most. That's of course the point. Checksum is gone. All right. Which is, a little bit friendlier to the end devices, although, how much bother is it really to calculate a checksum? But anyway, which protocol is gone in IP version 6? All right, I see a bunch of answers. Let's see if second one is the most popular one. And that's right, ARP is gone. SLAC is stateless auto configuration. DED is duplicate address detection. And as you all know, you need DNS more than ever because you really can't remember the blasted numerical addresses anymore. Now they're so long and complicated. All right. All right. And what's the addressing? You got an IPv4, but not an IPv6. All right. As I hear this said a lot, and people make a big deal out of it, although I'm beginning to have some doubts, of course. As you know, the broadcast is supposedly gone, but there is, multicast to all nodes. So this seems like a splitting of hairs. Anyway, so go ahead and finish your certifications, and I'll come back later and talk a bit more about Cisco. And you can start doing the packet tracers if you've already finished all this. And indeed, if you get tired of doing the packet tracers, we can start setting up on the real routers. What I would like to do, which I have never done, is get one of these PCs set up as a GoGo 6 tunnel to IP version 6, and then use that as a gateway to the real internet and take real internet traffic on IP version 6 and run it through those routers and sort it back out down here. We should be able to do that, but I've never quite gotten all the pieces working. So try it and we'll see.